Hello everyone, we are continuing Unit 8 about triangle similarity with Section 3, which will cover other proportional triangle theorems. So we've been using proportions to solve for missing pieces, but now we have these new theorems that are going to allow us to solve for some other missing sides when you don't have all of the information that you previously had. So we have the triangle proportionality theorem, which says that if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So if we look at this picture here, what that is saying is if you have some triangle, you have a line that divides through two sides of the triangle, and this line is parallel to the base of the triangle, then we have a proportion between AE to EB and AF to FC, which is represented right here. AE over EB is equal to AF over FC. So let's go ahead and solve an example. So we have this triangle here, and we're going to solve for the missing side of US. And I know that RV is 10, VT is 4, RU is 14, and we don't know what US is. I'm able to solve for US because we have a parallel line. So to start, I'm going to acknowledge that I have VU that is parallel to TS. So VU is parallel to TS, meaning that RV over VT is equal to RU over US. So now I can plug in my numbers and solve for my one missing piece here. So I have, in place of RV, I have 10 over VT as 4, which is equal to 14 over our unknown side of US. I'm going to multiply across. So I have 14 times 4, which is equal to 56. And I have 10 times our unknown side length. So that's 10 times our variable, which you could just use x, and you probably should. I'm going to divide out 10 on both sides, which means that the length of US is equal to 5.6 units. Now I was able to solve for that using the triangle proportionality theorem. All right, so that's the triangle proportionality theorem. It says that if you have these parallel lines, then the sides of the triangle are proportional. We also have the converse of the triangle proportionality theorem. And this says that if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So it's saying exactly the opposite of the triangle proportionality theorem. The converse is saying that since we have this proportion, AE over EB is proportional to AF over FC, that line EF and side BC must be parallel, must be parallel. All right, so let's look at an example here. We want to know in this figure, is DE parallel to BC? We're going to find that out by setting up a proportion between our side lengths. And if it's true, then they're parallel. So I have 8 or AE over EC is proportional to AD over DB. And we're not sure, so I'm going to put a question mark on my equal sign to let me know that I'm not sure yet. So I'm going to now plug in my numbers. So I have 8 over 12 is equal to 10 over 15, possibly, we're not sure yet. I'm going to solve using the cross products on this one. So I'm going to multiply across the diagonals. 10 times 12 is 120. And then we have 8 times 15. 8 times 5 is 40. 8 times 10 is 80. 80 plus 40 is 120, so this does check out. And because our proportion is equal, then DE must be parallel to BC. So DE is parallel to BC because AE over EC is equal to AD over DB. Sorry, that should be DB over DB. And that is our answer. All right, we're going to turn the page, and we have we have two more theorems that we want to work with here. So we have corollary. Technically, this one's a corollary, not a theorem. And it's the two transversal proportionality corollary. This says if three or more parallel lines intersect two transversals, then they divide the transversals proportionally. So in this image, we have three parallel lines, and they are dividing, or they're intersecting two transversals. So I have this line here that's going through all three parallel lines, and I have this line here that's going through all three parallel lines. Because we have two lines that cut through all three parallel lines, then they divide it proportionally, meaning that the distance between A and C to CE is proportional to the distance between BD and DF. So not only do we have the two transversal proportionality corollary, but we also have the triangle angle bisector theorem. And the triangle angle bisector theorem says that if an angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other sides. So that means that if we have a figure like this, where we have this angle that is bisected, then BD to DC will be proportional to AB to AC. So the base of one side to the base of the other side is proportional to the length of the first side to the length of the second. And we can solve using that as well. So I'm going to start here. We have example 3. We want to find PS and SR. And I can set this up as a proportion because I know that x minus 2 to x plus 5 will be proportional to 32 to 40. So I have x minus 2 over x plus 5, which is equal to 32 over 40. And I knew to put 32 on top because it is on the same side of the triangle as x minus 2, which I put on top in the first piece. Now I'm going to solve by multiplying the cross products or finding the cross products. So I have 32 times x, that gives me 32x. But I also have to do 32 times 5. 5 times 2 is 10, then 5 times 30 is 150, plus 10 is 160. And then I have x minus 2 times 40, again multiplying to every piece. So I have 40 times x, which is 40x, and 40 times negative 2, which is negative 80. Now that I have these pieces, I'm going to get x by itself, so I'm going to add 80 to both sides. And that is going to clear the way. So that means I have 32x plus, we have 16 plus 8, which is 24, so I have 240, which is equal to 40x. I'm going to subtract 32x from both sides, and that will leave me with one term that has an x, and it will all be on one side of our equation. So I'm going to subtract 32x out. That gives me 240 is equal to 8x. We're going to divide both sides by 8 to get x by itself, which means that x must be equal to 30. All right, so that was x, but that doesn't actually solve my problem because I want to know the length of PS and the length of SR. So I have PS is equal to x minus 2, but now we can plug something in for x. So in place of x, I now have 30, which means that PS must be equal to 28. So that's 1. Now I need SR. SR is equal to x, which is now 30, plus 5, which means that SR is equal to 35. All right, that is where we are going to stop for today. We will pick back up with section 4, which is going to cover a little bit more about ratios using area and